Dear students, now I am going to discuss about code conversion, that is decimal to hexadecimal and hexadecimal to decimal using 8085 microprocessor. Now let us see about decimal to hexadecimal conversion using 8085 microprocessor. Okay, so for that the first instruction is LXI H, 4200. So here we are initializing memory location 4200 with the help of HL register pair. Okay, so here we are going to give decimal data in this location 4200. We are going to give decimal data. So okay, so this is the input we are going to give in location 4200 decimal input. Okay, so then we are initializing A register 00 and B register as 00. Okay, that means we are clearing A and B register. Okay, so now we are initializing memory location 4200. Okay, so sorry, 4200, where we are going to give decimal data. Let us consider the decimal data is 10. Okay, so let us consider the decimal data is 10. Okay, so then we are clearing A and B register, A equal to 00, B equal to 00. Okay, so after that then we are incrementing B register and incrementing accumulator. So INRB means B register content will incremented by 1. For every execution, B register content increment by 1. And ADI 01 means accumulator. ADI 01 means A equal to A plus 1. Okay, ADI 01 means add immediate data with accumulator and the result will be stored in accumulator. Simple representation is A equal to A plus 1. Then decimal adjust accumulator, which converts the data which is available in accumulator into decimal data. Okay, so the data which is available in accumulator into decimal data. The data available in accumulator is hexadecimal, means that will be converted into decimal data using this instruction. Okay, so then we are comparing accumulator data and memory data. Okay, so in fourth step we are incrementing memory location. Now incrementing B register value, then incrementing A register value. In second step it is B equal to 01. After increment, B initially 00, A initially 00. So we are incrementing B register value and accumulator value. Here ADI 01 means A equal to A plus 1. Okay, so it is similar to increment A instruction. Okay, so both B register and accumulator is incremented for every step. Accumulator content is converted into decimal using this instruction. Then accumulator data and memory data is compared. Accumulator contains, after increment, single increment, accumulator contains 01, memory contains 10. Okay, so 1 minus 10. Okay, so here we are checking for a 0 flag. When 0 flag will set means when accumulator content and memory content, when it is equal, then the 0 flag will set. Okay, so now accumulator contains 01. After increment, accumulator contains 01 and the memory contains, this is decimal data. Okay, so this is 10 and this is 1. Okay, so after every increment, okay, so when both these data are equal, 0 flag will set. Before that it will not set. Okay, so we are checking for a 0 flag, it is not set, then it will goes to loop. Okay, so again we are incrementing B register and A register. Then in next step, B register is 02, A register is 02. Then decimal adjust accumulator converts the data which is available in accumulator into decimal data. Okay, so then comparing. Okay, so 2 minus 10, accumulator minus memory contains 10. So now also there is no 0 flag. Okay, so when accumulator 10 and memory 10 means 0 flag will set, otherwise it will not set. Okay, so up to that we have to increment accumulator value. Okay, so after 10 steps, accumulator value will be equal to after 9. So again and again if 0 flag not set, again and again this program will transfer to program control transfer to here. Okay, so when incrementing this, B increments after 9, B increment as 0A. Okay, so after in microprocessor hexadecimal data only accepted. Okay, so after we are incrementing up to A attains 10, we are incrementing accumulator and B values. Okay, so when after 9, B the value stored in B is A. Okay, so then accumulator also contains A. Okay, since microprocessor after 9 it will display A. Okay, it will not display 10. Okay, so that will be B register contains 0A, but the accumulator data is converted into decimal. Accumulator also contains 0A. Okay, so here hexadecimal data will be available in both B register and accumulator. After 9, here A is available, here also A is available, but the accumulator data is converted into decimal. Now it is accumulator contains 10. Okay, so accumulator data and memory data is compared. In memory we have given decimal data 10. We can compare two decimal data. Okay, so we cannot, it is not possible to compare two different data. Okay, so now we are comparing two decimal data. One decimal data is available in accumulator. Okay, after increment, each increment after 9 accumulator contains 0A, that will be converted into decimal. After that accumulator contains 10. So that 10 and the data which is available in memory, that is also considered as 10. Both are compared. After that 0, the result will be 0 stored in accumulator. After that 0 flag will set. If 0 flag set means B register data will be moved to accumulator. Now B register contains equivalent hexadecimal value. Okay, so after every increment, B register and accumulator contains same value. After 9, B contains 0A and A also contains 0A. Okay, so but this 0A is converted into decimal data using decimal adjust accumulator. Now accumulator, after this execution of this instruction, accumulator contains equivalent decimal data. Okay, so now accumulator contains 10. This 10 and the data which is available in location are compared. While comparison, if both the data are equal, we will get a 0 flag set. Okay, if 0 flag sets means move B register value to accumulator. B register contains equivalent hexadecimal value. Okay, that will be moved to accumulator. Now accumulator contains equivalent hexadecimal value, that will be stored in STA, means store accumulator data in this location 4201. Okay, so now this 0A will be stored in location 4201. We have given input at location 4200, where I have given as 10. Now at location 201 we will get result as 0A. So this is thing. Okay, so equivalent hexadecimal value is available in B register. Okay, so after we are checking whether accumulator data and memory data are equal or not. Up to that we are comparing. Okay, so when they are equal, we will get a 0 flag set. After that we are moving equivalent hexadecimal value which is available in B register to accumulator, and after that storing that hexadecimal value in this location, then program will get stopped. Similarly, code conversion using hexadecimal to decimal. Okay, so here hexadecimal to decimal. Here we are initializing memory location 4200 with the help of HL register pair. So now I am initializing memory location 4200 where I am giving hexadecimal input. So because we are discussing about hexadecimal to decimal conversion, so here I am giving 0A. Let us consider this is 0A, the input as 0A, and then we are clearing accumulator and then B register, C register. We are clearing accumulator, B register and C register. Okay, so we are initializing one memory location where I am giving hexadecimal data as 0A. After that we are clearing A, B and C registers, and then we are incrementing B register and accumulator values. So first step, accumulator contains 01 and B register contains 01. Okay, so then we are converting accumulator data. So here accumulator data, after every increment after 9 it will contains 0A, that will be converted into decimal, that is 10. After this instruction execution, accumulator contains decimal value equivalent to this value. Okay, so then we are checking for carry. So in hexadecimal maximum value is FF, its decimal equivalent is 255. Okay, so that 2 will be considered as carry. If value excess than 8-bit means that will be considered as carry. So if carry is available means increment C register, otherwise if carry not available means move A register value to D register. Now A register contains 01. After first increment A register contains 01, that will be moved to D register. Okay, so after that we are moving B register value to accumulator. B register also contains 01, that will be moved to accumulator. So A register value moved to D register because we have to move B register value to accumulator and we have to compare. So we can compare two hexadecimal data here. Okay, since in memory location we have given hexadecimal data and in accumulator we are in need of hexadecimal data. Okay, so for that we are moving the data which is available in B register is hexadecimal value, because accumulator value is converted into decimal value. So now hexadecimal equivalent accumulators equivalent hexadecimal value is available in B register. So that data moved to accumulator and then compared with memory data. Okay, so now B register also contains 0, 1 and 0, 1 and memory data will be compared. 0A will be compared. Okay, so 0, 1 minus 0A. So here also we are checking for after comparison we are moving D register data to accumulator. D register contains 0, 1, that will be moved to accumulator. Initially this data was available in accumulator, that was moved to D register, again it will be moved to accumulator. Okay, so then we are checking for 0 flag. If 0 flag sets means, that means if both the data are equal, when this data also A means 0 flag will set, up to that we have to increment. Okay, so now while comparing 0, 1 and 0A, there is no 0 flag set. So program control will be transferred to loop. Again we are incrementing B register. Now B is 02 and A is 02. Okay, M contains 0A. Okay, so then for every increment accumulator data is converted into decimal data using decimal adjust accumulator. After that we are checking for carry. If carry is available we have to increment C register. If carry is not available, program control will be transferred here. Accumulator data will be moved to D register, because we have to compare two hexadecimal numbers. Since accumulator contains decimal value, that was temporarily moved to D register, and then the hexadecimal value which is available in B register is moved to accumulator. After that, that hexadecimal data and the data hexadecimal data which is available in memory, both are compared. If both the data are equal, 0 flag will set. Okay, before that we have temporarily moved accumulator value to D register, again we are moving that value to accumulator. Okay, so when 0 flag set means we are storing, when 0 flag set means accumulator contains equivalent decimal value. Okay, because each and every step hexadecimal value is converted into decimal. Okay, so equivalent hexadecimal value which is available in location will be available in accumulator. Okay, so ஒவ்வொரு வாட்டியும் இன்க்ரிமெண்ட் பண்ணுறப்போ நம்மளுக்கு B ரெஜிஸ்டரில் ஹெக்ஸாடெசிமல் வேல்யூ இருக்குது, அக்யூமுலேட்டர்லையும் ஹெக்ஸாடெசிமல் வேல்யூ இருக்குது. ஓகேவா, ஸோ அக்யூமுலேட்டரில் இருக்கிற ஹெக்ஸாடெசிமல் வேல்யூ கன்வெர்டட் இன்டு டெசிமல் யூசிங் திஸ் DAA இன்ஸ்ட்ரக்ஷன். ஸோ இது வந்து கேரி செக் பண்ணுறதுக்கு. ஸோ சப்போஸ் கேரி இல்லை அப்படின்னா அக்யூமுலேட்டரில் வந்து இப்போ நம்மளுக்கு டெசிமல் டேட்டா இருக்குது, அதை வந்து டெம்பரரியாக D ரெஜிஸ்டருக்கு மூவ் பண்ணி வச்சுட்டு இப்போ B ரெஜிஸ்டரில் இருக்கிற ஹெக்ஸாடெசிமல் டேட்டாவை அக்யூமுலேட்டருக்கு அனுப்பிட்டு அக்யூமுலேட்டரில் இருக்கிற ஹெக்ஸாடெசிமல் டேட்டாவையும் மெமரியில் இருக்கிற ஹெக்ஸாடெசிமல் டேட்டாவையும் கம்பேர் பண்ணுறோம். கம்பேர் பண்ணிவிட்டு அதுக்கப்புறம் என்ன பண்ணுறோம் அப்படின்னா, ஆல்ரெடி டெம்பரரியாக D ரெஜிஸ்டரில் அக்யூமுலேட்டரில் இருக்கிற டேட்டாவை மூவ் பண்ணி வச்சோம்ல, அது திரும்ப வந்து அக்யூமுலேட்டருக்கே மூவ் பண்ணிடுறோம். இப்போ அக்யூமுலேட்டரில் வந்து டெசிமல் டேட்டா இருக்கும், நம்ம என்ன ஹெக்ஸாடெசிமல் இன்புட் கொடுக்குறோமோ அதுக்கு ஈக்குவலாக டெசிமல் டேட்டா இருக்கும். எப்போ 0 ஃப்ளாக் செட் ஆகுதோ அப்போ வந்து இந்த அக்யூமுலேட்டரில் இருக்கிறது வந்து நம்ம கொடுத்த இந்த ஹெக்ஸாடெசிமலுக்கு ஈக்குவலண்ட் டெசிமல் டேட்டா. ஓகேவா, ஸோ அப்போ அந்த அக்யூமுலேட்டரில் இருக்கிற டெசிமல் டேட்டாவை போய் இந்த லொக்கேஷனில் ஸ்டோர் பண்ணுறோம். நெக்ஸ்ட்டு கேரி இருக்கு இல்லையா, கேரி வந்து C ரெஜிஸ்டரில் வச்சுருக்கோம் இல்லையா, அதை ஒரு லொக்கேஷனில் ஸ்டோர் பண்ணோம். அதனால் ஏக்கு மூவ் பண்ணிட்டு நெக்ஸ்ட்டு 4202 ஸ்டோர் பண்ணியிருக்கோம். நெக்ஸ்ட்டு ப்ரோக்ராம் ஸ்டாப் ஆயிடும். ஸோ நம்ம செக் பண்ணுறது வந்து கிட்டில் செக் பண்ணுறப்போ இப்போ இன்புட் வந்து டெசிமல் டு ஹெக்ஸாடெசிமலுக்கு இந்த லொக்கேஷனில் 10 கொடுத்தேன் அப்படின்னா இந்த லொக்கேஷனில் 0A வருதான்னு பார்க்கணும். அதே மாதிரி ஹெக்ஸாடெசிமல் டு டெசிமலுக்கு பார்த்தீங்க அப்படின்னா, ஸோ இஃப் யூ ஆர் கிவிங் FF இன் திஸ் லொக்கேஷன் அப்படின்னா 55 in this location and 02 in this location. ஆல்ரெடி சொன்னேன் இல்லையா, கேரி 8 பிட் தான் மேக்ஸிமம் ஸ்டோர் பண்ண முடியும். ஸோ FF ஓட மேக்ஸிமம் வேல்யூ வந்து 255. This 2 will be considered as carry.